On December 29th at exactly 7:18 UTC, something extraordinary began. The sun's surface erupted with a violence we haven't witnessed in months. Within the next 24 hours, our star would unleash 3 X-class explosions and more than 20 moderate flares. NOAA's sensors lit up red. Radio operators across the Indian Ocean lost contact, and space weather forecasters asked themselves, is this the beginning of something bigger? Welcome back! For weeks, the sun had been restless but controlled. Active regions rotated into view, flared moderately, then faded. Normal solar maximum behavior. But December 29th shattered that pattern. What began as routine M-class activity at 2:35 UTC escalated within hours into a solar firestorm that reminded veteran forecasters of the great storms we studied in the 70s and 80s. Let me walk you through what happened, hour by hour, because this wasn't random chaos. This was a coordinated solar event across multiple active regions, and the implications are fascinating. But here's what makes this different from typical solar storms: the timing and the targets. Stay with me. At 7:18 UTC on December 29th, active region 3936 fired the first X-class flare, X1.1, strong but not catastrophic. 8 M-class flares had already preceded it that morning, like warning shots before the main event. Then came the quiet. 3 hours, just long enough for forecasters to exhale. December 30th, 4:14 UTC, the same region, AR3936, detonated. X1.5, radio blackouts swept across Southeast Asia, airlines rerouted polar flights. Amateur radio operators from Perth to Jakarta reported complete signal loss. 4 minutes later, before anyone could react, active region 3932 joined in. X1.1, another major flare. 2 X-class events 4 minutes apart. That's not normal. That's coordinated magnetic instability across separate regions. But the sun wasn't finished. By the end of that UTC day, 21 M-class flares had erupted. M4.2s, M7.2s, a relentless barrage. The GOES satellite's X-ray sensors looked like a seismograph during an earthquake. What's driving this? Multiple beta, gamma, delta sunspot configurations, regions 3936, 3939, 3932, all magnetically complex, all primed to explode. It's as if the sun coordinated an assault. And this raises the question scientists are debating right now: was this a statistical coincidence, or is there something about solar maximum we still don't understand? Here's what matters beyond the raw numbers. This 24-hour period produced at least 2 Earth-directed coronal mass ejections, one from the December 29th filament eruption, forecast to arrive December 31st. NOAA issued a G3 geomagnetic storm watch, the strongest alert in months. That means auroras over New York, Chicago, Seattle, power grid operators on high alert, satellite controllers adjusting orbits, GPS drift warnings issued to aviation. But there's context here. 2024 recorded 54 X-class flares, more than any year since at least 1996. This December surge, 3 X-class events in under 24 hours, pushes us even higher. Solar Cycle 25 is exceeding every prediction. Some scientists, conservative voices at NOAA, say this is normal solar maximum variability amplified by better detection. Others, the AV Loeb camp if you will, suggest we're witnessing magnetic field dynamics we don't fully model yet. What do you think? Are we just seeing solar maximum as expected, or is Cycle 25 behaving differently than past cycles? Drop your thoughts below. I'm genuinely curious where you stand on this. The active regions responsible, 3936, 3932, 3939, are still on the visible disk, still magnetically complex. NOAA forecasts a 25% chance of additional X-class flares over the next 72 hours. Translation: we're not done. This 24-hour solar eruption wasn't just a data point. It was a reminder. We live under an active star, and Solar Cycle 25 is far from finished. Thank you for watching, and here's my question for you. How many X-class flares do you think we'll see in 2025? More than 2024's record of 54, or will the sun calm down? Leave your prediction in the comments. Until next time.